Hello everyone, my name is Rinam Malik and you are watching Malik Robotics. From this video, we are going to start OpenCV tutorial playlist. In this playlist, I will teach you everything from basics to advanced about OpenCV. OpenCV is a very important library for image processing in Python. And of course, you have to know Python before starting this course. So if you don't know Python, then this course is no use for it. So let's start this course without any further delay. So these are the some prerequisites. You should know Python and you should know some basics of Matplotlib. And if you know some basics of NumPy, then this will work great because we require this programming language Python and these two library in this course. So let's start this video. So first is contents. Let's start with that. Then first is introduction part, which is currently going on. I'm just telling you about this course, its workflow, etc. After this introduction, in this video, we will cover image operation. Image operations are the basic operation we are going to cover. You will see later in this video. In the second video, we will cover image segmentations, which consist of segmenting the image and making counters so that you can identify that this is bad in the image or this is the teddy bear in the image, etc. After that, in third video, we will go for cascade classifiers. After fourth, we will go for image analysis and transformation. In fifth, we will track the object and motion of the object, of course. After that, facial landmark detection and face swaps. Face swaps like my face in front of my girlfriend face, my girlfriend face in front of my face. Like swapping. Chew. After that, we will work with videos. Videos are generally photos coming together. It's like we have heard the term of FPS. FPS means frames per second. It's like your video is running at the speed of 60 FPS. That means 60 frames per second. Like frames, you consider frame like one photo, like one photo, second photo, third photo, fourth photo, and so on. It's like that 60 photos are coming in line in 1 second with equal gaps. So this is the video. So after we have done all the you know s- editing of images and like this or that analysis, transformation, tracking, etc. on one photo, we can do of course that videos. It's like just iteration process. So after this, we will be done about this OpenCV course, and then we will do projects. I will first I will do one or two projects in front of you. We will do it together because you know I am also like a student like you. So we will do the projects, and of course recruiter love the projects, and you also. We after doing the project, we feel like we have done anything. So that's all. Let's go on the introduction and complete the introduction. Yeah. In introduction is first is about OpenCV. I have told you about OpenCV. It is an open source computer vision and machine learning software library designed for tools functionality for various tasks related to computer vision, image processing, and real-time computer vision applications. Like blah blah blah. It's all definition. It's like for image processing, we use OpenCV because it's best library. The next tool we are going to use is Google Colab. Google Colab is just an online library. Wait, I'll show you. Yeah, this. It's online. Actually, sorry, I told you library. It's an online IDE which is given by the Google, and the benefit of it is it have you know GPU, T for GPU and TPU for low end PCs. If you have low end PCs, no worry, it will do everything online. So we will use this. And after this course completed, or after this video is completed, actually, I will give everything you on the GitHub, and I will put that in the description link. Let's go. Let's start the course. It's quite getting boring of this theory. Let's go, waves. Image operations. So this is the content of the video. First, we will go for some basic operations, how to load the image, how can we can see the image, what can we do in Jupyter notebook, what we can do in the Colab, how could we access that, etc. etc. After that is like we will do on what is grayscaling the image, how to do it, etc. After that, color spaces, then drawing on the images, then transformations, and so on. We will go and go on this video. This will end in 1 hour or 1.5 hours. So let's start this video. Not make it landy. Uh, okay, let's go. Opening the Colab. This is our Colab notebook. Okay, so first we will need to import some libraries. What is the first libraries? Import numpy snp. Wait. Yeah. Now you can. No. Yeah. It's like looking visible now. Import cv2 scv. This library is cv2 library. If you have not installed it, like pip install is like generally one statement you will get on Google like this. Pip install opencv python. Mm, ah, this this is the achievement. This how geek for geek. It's and very good site. And like this, if you don't know anything, just Google it. Google it or use ChatGPT. I'll just teach you everything. That if you stuck in a problem, like I was stuck in the problem in this course, of course, I'm just a human being, not a computer. So we will see how to solve a problem in like in coding. Okay. So where were we? We import NumPy as NP. NumPy is just an standard library for numerical analysis, and CV2 is our OpenCV, and after that we will use matplotlib. I will tell you why we are using matplotlib. Matplotlib, not just shift enter to run this. Okay, now first I will teach you how to write in normal IDs like Visual Studio or etc. In that you will like create an image equal to np dot zeros 512 comma 512 comma 3. Okay, so this is an numpy functions np dot zeros. What this do, I will show you. Wait. Okay, so what this things does is like it make an np array of zeros, and the shape is like 512 512 comma 3. Like you can see this is 5 3. It will divide like 512 512. It's a structure you can not visualize, and you can't see like that. And uint 8 is an data type for images we generally use in this. Okay, if you are using a normal id like Visual Studio Code or etc., then you can show this image like cv dot im. So the name of the image, after that img. You have studied this before, but it will give an error. Why this error? Because Google Colab or Jupyter Notebook does not support the cv.imso function. So, how should we access the picture which we are editing in the Colab? We will make I am so function ourselves. How can we do that? Yeah, we will do it with the help of matplotlib. Let's go on that also. Just remove this plotting image using matplotlib. Oh, img equal to we have already uploaded the image like plt.imso function img. This is a matplotlib function which we use to show the images, and plt.access. I will show you what this function does in 1 second. Wait, plt dot. So this is yeah. This functions take the images. This function tell that access should be off or not. Is like this. And plt dot show is like just show our image to us. Yeah, this is the image which we have created here. You can see there is no axis, and if we just comment out this is the axis of our image. So this is the technique. How can we do plotting of our image in Google Colab? Let's start the OpenCV part. So first, when you have installed the OpenCV, just check the version to confirm that you have installed it or not. Ah, so you know that I make so many mistakes, very much mistakes, like import CV2 as CV, and here is like what is CV2? He Our collab does not know what is CV2. Like remove this. Now it will give the version. After this, I will give you the link of the repos. Uh, this link will be in description. This is the image link. wget. This exclamation wget. We use this function to download the images from this link. The images will be in the zip file. You can see the .zip. To unzip, we use unzip function, and this like image.zip //q image.zip. This in this format, we can download image from any site and unzip it. Let's run this cell, and for your practice, I will add this link in the description. And if you want to practice on your own image, then it's okay. Like you can see, it's like downloaded files, image. Yeah, these are the images which we have downloaded and unzipped. Let's start and plotting some images. So let's go. First, we will take some image. Which image do you want? Mhm. Which image? Like, yeah, truck. Just copy path and image equal to cv2 dot imread. Okay. So this is imread function. cv2.imRead function just read your part. No, it just read your image, and now we have to plot it. Remember how we plot the graph? Is like plot dot I am so image. Let axis be on and plot dot so it will load our image. This is the truck at the sunset in desert. So what we will do is like why we will do this whole process again and again and again. Let's just copy selection and make a function. I am so we will put title. In title we will give null value. The image we will none value too. So plt dot I am so wait. I will explain you in 1 second to see. Okay, so this is the function we have created to show the image. What this function generally does is like is it contains some title which we will give as input and an image. It will show the image like plt.im so cv2.cvt color. What this color does is like it convert bgr to rgb, and you will ask why we are converting bgr to rgb, because in you can see that this image is like sunset and a truck, but can you observe some colors are different in this image? Yeah. So in this image, the color are different because it is in BGR format. We have to convert from BGR to RGB to see the real image. So do you want to see the real image? Let's go. Let's activate our function and use it. I am so title we will give truck, and for image we will give image. Uh, you can see it's a RGB image. It's a BGR image. By default, we our Metro OpenCV read is like this, but our Matplotlib love the RGB format. So we have to convert it like from BGR to RGB. This is the real for. Here is no sunset. Here is just an open sky, and the color of truck is yellow, not the blue. You can see the difference. So let's go. Now we have read the image, we have plotted the image, but what we have to save our image. If we have to save, it's like just cav2.im write function, put dot jpg. Yeah, this is the name of the file which we have to save, which we want to save, and this is the file image. And this is im write function. This used to save our image. It will give true because our image is saved. Wait. Mm, this is output.jpg. You can see our image. Okay. So I have a question for you. You have wait. You have seen that this this shape gave this picture. So this picture have some shape. Let's see what shape it has. So we will use dot shape function from numpy to see the shape of the image. Let's see image dot shape 200 300 comma 3. So what is this 200 300 comma 3? Uh, you can see it's from 0 to 200 and this 0 to 300. So what is 200? 0 to 200. What is this? This is the height. 0 to 200 is height. 0 to 300. This is the width. And what is this? This is the RGB channels. It have three channels like RGB. And how can we suppose to see that? I will show you this. This is our image. So this is the height. This is the width, and this is the RGB, like how much content is of blue, how much content is green, how much content is red. This is a three-dimensional image, and our photo also have three dimensions: this height, this width, and this RGB. Let's focus what is height, width, and shape. Shape is not shape, it's like channel. Height, width, and channel. So height equal to int image dot shape, and we will zero to index. Just copy and paste. For tech lover, copy paste is like an heaven thing. Just change one to uh, print the height of the image is H. Control C. Control V. Okay. So height of an image is 200. The width, wait, spelling error. Yeah. So the width of the R image is 300 and the number of channel R image contains 3. And what are the number of channels? RGB. So these were all the functions, you know, the basic functions. Very, very, very basic functions. Just yeah. You have to know this will tell you how to import, how to write, and etc. You will able to save the image, load the image, and column. Now, our second topic is grayscaling the image. You can see this image is in RGB format. We will convert it in black and white format. Okay, just we will make new notebook here. Just grayscaling our image. Oh, I know previous section was little bit boring because it's just how to import an image, how to load an image, how can plot in an image, and what is height, width, etc. of the image. But from here, we will do some process on our photos and pictures. Let's start. First, we will import some libraries and our function. This function. Just I'm copying and pasting cause it will get boring. But I recommend you so you will write it again and again and again so that you will not just forget it. Grayscaling the images. Uh, we will do something more to this function. Now you will ask what we will do more to this function. It is like will give a size equal to 10 size. Yeah, we will focus on the image and w comma h. We will take the width and height of the image. Remember what is the width? What was the height? Okay. Oh, wait a minute. Width was first, height was and then we will mention the aspect ratio. Now you will ask Rudy. Uh, if you don't know, Rudy is my nickname. You can call me Rudy if you don't want to call me Rhythm. Okay. You will ask Rudy, what is the aspect ratio? Aspect ratio is just, you have seen that television or in your mobile phone aspect ratio. This is the aspect ratio. Width ratio height. This. Generally, this is on HDTV. Okay. So this is just generally our aspect ratio, and we will maintain our aspect ratio of our image. Let's go. So this is our aspect ratio. And now plt.figure. What is this does? This just make an empty figure of the size we are telling it to. Just wait. Fig size equal to size. mm, Aspect ratio. Size into aspect ratio into size. Let's import some image. You know, to check this, just Control C, Control V. Images. We'll take this, copy part, cross this, image equal to tell cv2 dot imread and a part of our image. We will use our imso function. We will specify Kestra and image. Oh, sorry. I told you I do many mistakes and very silly mistakes. Yeah, this is a Kestra. A cute landscape, but what we have to change its size parameter which default value is 10. Let's make it small, 5. Oh, you can look so tiny image. Let's make it blind. 20. Double size. Mm, yeah. See this, the size just increased rapidly. So we have made our function. We have done everything. We are ready for starting it and changing it to grayscale. First, gray image. We make a variable name gray image. It's better for understanding. Then cv2.cvt color function. CVT color. This function take first image, and after image it have we have to mention the format bgr to gray. So it will change from bgr to gray. Oh, why I do this mistakes again and again? CVT, CV2. Yeah, this is the function. Our gray image is ready. Let's go. I'm so gray image, and name of the variable image is stored. So this is the image. It's pretty simple. You know, we can do it another way. How? Just like I am so function gray image in other way, and here just write image. Where is the image? Where is the image? Where is the image? Here the image. Just slash 0. It will just make our image in binary. Look, we have showed our image, but it's in binary, so it will so black and white. Mm, just make it normal. Le- let's see the shapes. Image dot shape and gray image dot shape. You can see it have 1 2 80 9 60 slash 3. This is RGB panels, and it does not have RGB panel is only width and height. And how it's divided is like I will show you. So this is height width. If it's completely zero, wait, yeah, completely zero means black. Remember we have made an np dot zeros which gives us black image, so that is because why 0 means black and 255 means white. These are the some deviations of 0 and 255 how our grayscale images are made. Okay, wait. After this, our this was enough for our grayscale image. Now you know the both of matter how to convert an image to grayscale image. But we are talking about the grayscaling of our image, so we should also talk about the color spaces. Okay, so what is color space? Color space just the RGB panels which I have shown you before. Uh, Let's split our color spaces. Let's split our image in three channels: B, G, R equal to CV2 dot split. CV2 dot split function just split our images in the channels. Wait, I will show you. Image, bro, image. Print. B dot save. Ah, yeah, 1 to 80, 960, 1 to 80, 960, 1 to 80, 960. What was the 1 to 80, 960? So it's split in the BGR format. So if I will run the IMSO function on the blue channel, what output do you expect? Uh, I know some of you expect that it should run blue, but yeah, this is just like blue in the binary. Wait, this is only one channel like this. So 0 to 255. It does not have blue content. So, but it is the blue intensity. I will show you it. Uh, just copy this function, Control V, Control V. Here we will use D. Here we will R. Just change red. Here we will use green. You will see. This is the intensity of blue. Here we have white, so we have very much blue. Here we have black, so no blue. Exactly. We have here no red. Here very much red, green, no green, very much green, no green, green. This is the content of green. So the question now arises is how to convert our image in blue, green, or red. For this, we will make an blank image like we have made it before. 0 is equal to np dot zeros, and the shape is like shape of image. Image dot shape 0 and first. This will take 0 and first element, and we will mention the data type as uint8. Oh, I know I just do this silly mistake several times, and I will do. You will also do. No, no one is perfect, and I'm not at all perfect, but we all just trying. I'm also trying. We'll make something out of it. Let's start. Zeros. Here are black image. Okay. Now I'm going to show you most amazing function of the CV2 library, which is cv2.merge. Let merge. I am so red. cv2 dot merge. What it does is just it merges two images. Here we will merge two images like zeros, zeros, and red. It will merge in this form. It's like its height is of zeros, width is of zeros, and then its channel is of R. Let's go. we have finally made a red image. Congratulations. This is your first filter you have made from OpenCV. Let's make other filter also. Just change it from R to G, R to B, change the name, blue, and from red it's green. But it will give you the red image only. I'll show you how. See, cause this will be in BGR format, like B, G, and R. Zeros, zeros, and zeros in BGR. It's first frame of B, G, R. In BGR, height and width is this. BGR height and width is this. For red, the height and width are this. So it is zeros in BG. So it's like black. It's only red. Wait, I'll show you. Sorry, where is green? We will BGR format. So green is in middle. This and blue will be at the starting. Now you can see this is the green image, this is the blue image, and you can add blue and green in one image, like r- let's convert G and R. Ah, it's pretty cool, you know? And let's merge all of it to make an RGB image. I know it's like a little bit interesting from previous sections. Not that much interesting, but it is. What about we boost one color more? Like we will boost, wait, control that, control C. Let's boost one color, blue color. Sorry. Yeah. Ah, it's not a good picture, but yeah, blue color is boosted. You can see it. Let's make some HSV images. First of all, what is HSV? It is like an RGB is a pattern of an image. BGR is also a pattern. Grayscale is a pattern. Likewise, HSV is also a pattern. H for hue, S for saturation, L for lightness. Okay, lightness go from black to the color to the white. You can see it. Saturation goes from white to the color. It's increasing the color. You can see like white, then color content is coming, 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 coming. And hue select the colors. So HSV select these colors. And let's convert our image in HSV format. HSV image HSV image equal to what we will do is that cv2.cvt uh, color in computer vision or in any computer language. When we specify color, we write color. We does not write u. It's like this in the computer language program. I don't know why they have written like this, but it is what it is. cv2 dot color bgr to rgb. Let's show this image. I know. Now you want to hit me, but what I can do? I like this. HSV, and wait a minute, my PC just got stuck. Yeah, HSV slash image. Oh, mm. You can see this is pretty bad image. The color is like something. Wait, HSV. Yeah, yeah. You just first we have to edit a function. Where is a function? Where is a function? Just let's do this. Yeah, it will not work. I know. I knew it, but I want to show you that if someone want to change this like that, but it will not show you because our matplotlib and our collab and matplotlib loves RGB image. I have told you earlier that matplotlib love RGB image, so it will convert to an RGB. It will only show you RGB image, so it was converted to HSV, then HSV is converted to RGB. That's why it's like this. Now, I think it's enough for this section. Let's jump to the next section, uh, which is let's open our PDF. Drawing image and shapes. Yeah, you can see this girl drawing the shapes like stars. It's easy like this only. Let's draw some images on the black image. Okay, I was just saturating extra. Oh yeah, just water break, a tiny water break. You just stay hydrated all. Okay, so I know this all was just interesting for someone and boring for someone because we are just covering the basics stuffs like you know changing it to grayscale, RGB, making our content extra, converting it to HSV and other color spaces. These things are look like that they are very small, but when you go for bigger project like autonomous vehicles and etc, they are very useful. They are that mm, like 1 to 3 of number system, so you have to learn the numbers so that you can add it to the things. So that's why these things were very important, and now we are jumping on the drawing the image. And this section is very important. It's very easy section, but it's important cause this will help you in autonomous vehicle projects if you will do ever in your life. Let's start this section without wasting our time more. Let's go. Yeah. So I just come back to my collab and make a new notebook. Mm, over image. Okay. What is the first step? What is the first step? We just copy the cell, copy the selection. just paste it, and libraries will be important. And after that, we will import the images. Control C. Ah, yeah. Collab does not means Collab want you to have minimum sessions because everyone is using it. So you have to close some sessions. It's like just close this. Okay. Now after that, we will copy the function we have created. And now we are ready to start this section. To start this section, first we have to create a blank screen. Oh, how will we make a blank image? It, let's make a blank image. Blank image. np dot zero. Oh, we will use np dot zeros, which is numpy function, which will provide an array of the image 512 of the image, say 512, 512, and 3. 3 is the channels, and just np dot uint 8. Just copy it and paste it. Remove the channel. Now you will ask what is the difference in these images. I'll show you. Wait, I'm so blank. Okay, you can see that these two images look like same very much, but this image take 3 times space from this image causes up three channels RGB. And now you will ask why we need RGB channel for a black image? Because we have to draw something on this image and which have the color. So of course we need something like RGB. You know that's why our colors will show on this image. In this, the drawing which we will do will be like white only. So we have ready to start drawing. First thing is we have created a black line. First, we will draw a line on this image. CV2. First of all, just copy this one, Control C and Control and just CV2 dot line. A line function just draw the line. You know, you have just have to give Name of the image. Our image is this. After that, we have to mention the starting point. Let's start from 0, comma 0. After that, you have to start the ending point. Let's what is it? 500 now. Uh, it's like more than 500. So let's write 511 plus 511. After that, we have to specify the color. B, G, R. This will give a red line because it's R is like 255. After that, we have to give the width. Oh yeah, my bad. I just have to use IMSO function. IMSO function, and it's like red. No, it's like line, and this will go like black image. You can see this line, and let's make it width. You can see it just got thinner. Let's change its color. What is what is green plus red? What is green plus red? What is green plus red? It's yellow. So our line is converted to yellow. For second, just now copy this image, paste it, and we will now make an rectangle. CV2 dot rectangle. For rectangle, we will use blank image, starting point. Let's change in the starting from 200, and of course rectangle. So we have to give different points, 300 to 250. This is the color code. This is the thickness, and here we have to change it from to line to rectangle. Rectangle. Let's see. It will give the white line according to me. Yeah, 255, 255, 255. RGB 255, 255, 255 make white line. Okay, so let's make circle now. Just change here from line to circle, blank image. We don't want starting point in the circle, of course, but we want the midpoint. Circle is like dot and here. So this dot is center point, and we will give it 350 to 350. And instead of ending point, we just give it a radius, and the color combination, the it's 0. I will show you what this. Sorry, one. What this one is called. The Let's make it green. You can see this circle, but it's not filled. So what this one does is it does not fill it. But if I convert it to -1, it will fill the color. Yes, this is how our circle is made. Now, what if I want to make an polynomial? Let's make boomerang. Shape of boomerang. Do you know the shape of boomerang? Let's plot it. Here we will like points. No, points and p dot array. This will make just numpy array. This function. We want just One, two, three, 4 points for boomerang. I think one, two, three, uh, 4. 4 points and just add 2 points and we dot in 32. In 32 is just the number. It will be data type of int. Let's give the point. First point is 10 to 50. Just pick the random number. It will decide itself. 90 to 200, 50 to 500. Okay. Now, our point, just remove this. We have made the points, but our points are in the shape like we did. Just it. There are two channels, but we want three channel image. So we will convert it by writing the code PTS equal to PTS. We want to reshape it. So just write reshape function. It's so simple. Python is so simple. Just a basic English. Our point are just reshape now. Now just use save it to dot polylines function. There are many other functions which you have to check out on your own because I can't take every single function here. I am just teaching you basics for the other parts of other videos and other parts of this playlist, and just teaching you basic. You know, you have to just do some research yourself because I can't spoon feed everything to you. Just wait a minute. Oh, sorry for the you know just ah this is a polynomial. What does I just really write here? Blank image. We have given the points, we have given the color, we have given the weight. But what is this true here? Let's convert it into false so that we can know what is this true here. Uh, okay, so this false means this last line will not connect to this. But if we will write true here, this will got connected. It's so simple. Okay, so now just write something, uh, just give it a string. It will write something on an image. This is an image. Change it into a string. String 2 equal to Rudy love you all. And here we will write put text function. Here is the image. Here we will give the string. Okay. After this, we will tell the left starting point. You know, left starting point. I will show you what is left starting point. Although you should know, but I will tell you. Comma 290. This is our left starting point. Then we will give the font cv2 dot font Hershey complex. Ah, sorry, it just I ran it by the mistake. Hershey simplex. After this, just one. Rudy loves you all. You know it's got in red. What does this tree do? Oh, it's just a bit. What does one do? Actually, this will increase the space. Space in the word letter. Yeah, Rudy loves you. I just want it in the metric form. Wait, have we watched Matrix? It's not very nice movie. Let's go. Rudy love you all. The Matrix form. Okay. So this chapter ends here. What we have did so far. Yeah. We have done the basic operations, we have done the grayscaling of the images, we have done color spaces, drawing the images, and now it's time for transformation. What is transformation? What is transformation? Transformation, translation, and rotations. First is transformation, then translations, and then rotations. In this, we will do perform image translations. What is the translation of the image? Okay, so translation of image is just this. An image and whole image is just like down. It's not just cropping. In the cropping of the image, just we just crop it, or in resizing of the image, just we make it small. But in translation of image, just we move the image from here to here, and it's all the black part. What is the rotation? Rotation of image is like this. You can see this is rotating, rotating, rotating. Okay, and after the rotating, we two types of rotating, and after this flipping. Ah, here is no flipping. Let's done some coding on this. Oh yeah, okay. So let's start the translation of the image. I think we have. Let's create a new notebook. Close the old one. Mm, Transformation of image. image equal to, let's see the images. Where is our, oh, elephant. I love elephants. Copy part, image equal to cv2 dot imread and a part. I'm so elephant and the image. Let's see the image of our element elephant. Oh, it's quite large. Let's make it small. Five. Okay, so this is our elephant. What is happening to me? I'm saying element to elephant. Okay, just store the h and w quarter height. Quarter height. Quar. We have taken quarter height, quarter weight, so that you know we can translate it. First of all, translation come from the mathematics. And wait, sorry. Hmm. Yes, translation come from mathematics. And in mathematics, this is a translation matrix. So we have to make an uh, function, a refine, which is in like this structure. Let's make the function. Let's make a function t, which is consists of np dot float with 1 1 comma 0 and tx. In tx we will add quarter width. Quarter width. Okay. And what is the next? We will put 0 comma 1, and for ty we will add quarter height. Okay. Now we will use the function warp affine, which will make our image no. You remember what we are doing? Okay. We are doing translation using translation matrix. Okay. Let's so our I'm okay. So let's show our image. What the image we have made? Oh, the image we have made is translated img translation. Okay, Okay, so what does this say? Float most one argument got to. Ooh, 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 ooh. Okay, so this is array of array. Wait, array of list. Oh, what's this? Yeah, I was waiting for this something error like this. Although I know what's the error, but I want to show you this. Just copy this, and if you got some error in between, just open ChatGPT. Hey, ChatGPT. It seems I have a couple of Rapafine is Wasp-affine. Yeah, so Warp-affine it's Wasp-affine, and float it should be float 32. Yeah, just like this. So simple. What here is Warp-affine, and it's here is float 32, and T is not defined. Okay, so T. Do you see that? Our ChatGPT made our work so easy. It just see the code and tell us the error which we have did in the code. Okay, so let's see what the T is. 1 0 and this 0 1 and this 1 0 and this 0 1 and this. It's correct in the form of T. What is our H and W? H and W 519 and 778. 519. Oh, oh yeah, height is 519 and width is 778. Correct. So this is the translation, how we do the translation. Now we will do the rotating. How to rotate an image. How to rotate an image. What is rotation? Uh, this is the rotation. You know, rotating continuously is like you, or this is also rotation. Yeah, let's. Mhm. Let's start the rotation. First of all, we will do everything on image. So we will make an rotation matrix. Rotation matrix. We will use a function cv2 dot get rotation matrix 2D. Or in this we will take width height by 2, 90 minus 1, and we will use warp find function to align it. You know, here we use translation matrix, so here we will use rotation matrix. Rotation matrix. Now I am so rotated and img. Oh shit. Mm. Image is rotated on this axis, but what if I want to rotate it in a ladder axis? Wait, here -1 we will convert. Okay, now you know what is this one stand for, and this 90 is angle. I can take it 70. You can see it's just rotated like that only. Just converted 90, and this is on low. What if we take W hole and height hole? Oh, what just happened? What just happened? Hmm. Here we stuck, है ना? Oh, sorry. Here we stuck. So we just copy the code, Control C, and you know what? We go to ChatGPT, paste the line, and it will explain the parameters. Center X and center Y. Okay. Center X represent the coordinate of the center of rotation, which is the so. Okay. This is the rotation center. Means here and here. This is the center. Center. Here image will rotate like this or this. So we can't change it. It's half is the best. Okay. This was the first method to rotate an image. We have another methods to rotate an image. I will show you. Wait. Rotation. Let's make an variable rotation 2 and cv2 dot transpose. You have studied in transpose in math. It just make this to this, this to this. Just, but I don't prefer to use this method because this just give you less features. Uh, just rotated image. Yeah, so image is rotated, but here you can't, you can't select that in which direction should it rotate or the axis of the rotation and other things. So I prefer to this type of rotation than this. But yeah, the benefit of this is like it is whole image. Here it's some blank image here. Okay, now let's go our section. What we have done? We have done translations. We have done rotation matrix 2D, rotation with transpose. Now flipping an image. Let's flip the image. For flipping the image, it's only one function we want to use. It's like flipped equal to cv 2 dot flip and image comma 1. I am so horizontal flip, and it's like flipped. Okay, so our image will be flipped. You will ask Rudy what we have done in the image. We can't see. So let's plot another image, original image. Original image. Uh, so this is original and this is flipped. Yeah, it's flipped with the vertical axis now. So this is what -1 source. So we end this section here. Now moving to next sections, which is scaling, resizing, interpolation, and cropping. Okay, in scaling, resizing, interpolation, and cropping. First, we will learn how to resize and scale an image. So first, you have to learn what is resizing and what is scaling, rescaling of image. So this is the scaling of image. No, the image is original. It's 30% down and it's 300% up, but its quality is same cause its aspect ratio is same. In rescaling, our aspect ratio will be always the same, but in the form of when we are resizing the image, wait, I will see you. Sorry, I will show you. Yeah, just don't see this because focus on this. These are some resizing algorithms, and this is our reducing reducing the size. Original image, first algo, second algo, third algo, fourth algo. You can see that image quality is going down and down because aspect ratio is not same. But in the scaling of image, the quality stays same because the aspect ratio is also the same. Uh, wait, okay. This is the enlarging of image of different algorithms. So this was all about resizing and rescaling. Let's practically do it. Okay. Ooh, ooh, sorry. Yeah. Oh, first step. What is our first step? We will take an image, new image. Okay. Uh, Oxford Library. Perfect. We'll take this. So image equal to I am so, and just don't forget the eh, what. Okay, sorry. Sorry, just no. Let's say it's going too long. I just didn't thought that it would be so long, but never mind. We'll do what we are doing, like original image. Okay. Ah, it's pretty good pictures of Oxford Library. Board is quite visible and quite not visible. Okay, let's start our, you know, changing the things. What we will do with these pictures. First is we will resize it. Okay, what does resize means? I told you that just this thing. You know, see, 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 image going up. Okay, enough jokes. Let's start. CV2 dot resize fx fy 0.70. Okay, so our image will be resized. You know, we have done that. X-axis will be 0.75 and y-axis will be 0.75. So what this says that our size, image size will be smaller. Wait, I am so okay. You know, it's pretty same, but you can see the axis is 0 to 12,000, 0 to 800. It just got pretty small here because we have done the x-axis 0.75 and y-axis 0.75. And let's scale it up. Oh, mm. Oh, scaling up. Yeah. So enlarging an image. For enlarging an image, we will use an algorithm. So first we will use which one? Which one? It does not have that algorithm which I'm going to use, but it's pretty good and you can see it yourself and I will use it. Wait. Control C, Control V, our favorite thing, and Control C, Control V. It dot resize, image, none, fx equal to 0.75, but it will be, let's, oh, oh, interpolation method. Oh, if a math student, you will know what is interpolation. But if you are not a math student, you will not know what is an interpolation. So I will give a short note what is interpolation. So interpolation is basically is like finding a point on a known part. It's like this is a part. It's like this, and road is like this. But after interpolating, we find a point yellow point like this point, and this part is like this. So we find a point to cut the part. Okay, and there are some algorithms, and here cubic is better, and what we are using is cubic because cubic is better. I'll just compare in front of you and you just tell which one is better. Okay, let's just try with different algorithm. Okay, after intercubic, we will try with internearest. Nearest. After the nearest, we will try it with inter area. Area. After inter area, like just compare these three. Oh, okay. Resizing down. Cubic, nearest, and area. It's intercubic. 25,000, 25,000. But size is same. No, these are the same, but if you zoom in, it's like quite visible, less visible than that, but it's still visible. Uh, it's very low quality. Okay, so you can try other algorithms as well by yourself. Let's start with what is an image pyramid. No, wait. Okay, so what is image pyramid? Image pyramid is just functions. Wait, first giving the heading image pyramids. Okay, so image pyramids are the functions, you know, which are self-written, like pyr down, pyr up, and it's like smaller, even smaller. It's not even smaller, it's even smaller. You know, first we will make small, then original, then larger, then even smaller. It's just same as this, but with less features. No, smaller, original, larger, even smaller. It's less blur because it's more smaller than we have made already. It's small. You know, it's like smallest. No one likes smallest. Okay, so let's go to Canva. We have done how to resize and scale image. Scale for scaling, uh, wait, I will show you the scaling part. Where the fuck is the scaling part? Yeah, for rescaling the part. Wait, where are the code? Yep, simple dot resize. Here is like image. After image, we have done none. Okay, It's- but we have to have same aspect. Then we have to first find out the aspect of the images, and when we will find the aspect of the image, we just put it here in the place of none, so that our aspect will be same. Okay, and if we have to change the aspect, then we can change this value. So image pyramid done, image scaling done, image resizing done, and now what is the cropping? I know you can crop the R image. Is like it's very easy to crop an image in the phone app, but in computer vision we have to crop an image. So it is done by, wait, how it is done I will show you. Just first take our height and width, and of course start row, start row, and start column. You know, start row and start column is like from where to start and where to end. Crop is like, hey, from here our image will start, and from here our image will stop. Okay, so int h star, um, we'll say 25% for starting, and we will take 75% for ending. Now we will make an variable cropped. From here we will select start row will and okay, this will from start row to end row, start column to end column. Our image will be just cropped. Let's see. I am so cropped, cropped. Yeah. Okay. So this is the code. Just a little bit mistake. I have made it correct. So this is the cropped image. The original image was this without blur, and this is the cropped image. Now, what we can make is like, you know, let's draw a rectangle from on original image, that how our crop image will be. So let's first make our image, copy of our image. Then we will draw an CV2 dot rectangle, and here we will like copy, and here starting point is start column and ending point is end column. Column, start row. Start column, start row, and it's and column and row. Oh, that is color and that is our width. Let's see the rectangle. Oh, so this was the this part. Yeah. So this is how we can crop our images, and now this session is also come to an end. Now very less, very little things are left in this video, and we are very much close to the end. Let's see what is left in our video. Oh yeah, sorry. Yeah, one, two, three, four. Only four topics are left. So let's finish them. Let's finish them in this video only. Arithmetic and bitwise operator. So first of all, what is arithmetic operations? Arithmetic operations are simple operations that allow us to add or subtract the color intensity. Like color will be greater or less, and in bitwise we just add one image on other image. Uh, I will show you in the coding so that you can understand well. Okay, so let's start. Okay. So first step is we change the name from untitled to arithmetic and bitwise operator. Then we import our libraries, import our pictures, and then we made a IMSO function so that we can plot an image in pyplotlib. Okay, so we will choose this time London Xmas. Oh, I love Christmas. So we will choose this. Let's take image equal to function is cav2 dot im read to read our image, mention the path. Now let's see our image. I'm so variable of the image. Sorry, name of the image is original, and then the variable of the image. Yes. Uh, let's see the image. Oh, it's pretty nice Christmas. But to make you more, yeah, to make you understand more, like more fastly, we will take it in black and white. You will understand if there is only two colors. Yeah, we have taken it in black and white. So what I have told you about arithmetic operator is that arithmetic operator is used to may add the colors or remove the colors, means basically to change the color intensity. So let's change the color intensity. Like first we will make an variable r which will contain np dot ones uh, in the shape of our image dot shape, and our d type is of course uint8 like every time, and we will multiply it by 100. Np dot 1 is 1 in the image shapes, but so r will be 100. Okay, so this is r. And what is our image? Our image is this. Okay, so this is our image. uh, if do you want me to show you the R, then I will plot it. I am so white image, and it's ah see this grayscale. This is the R which we have made just right now, and now we will add it. Add cv2 dot add function. You can see that these are so similar function to its name. It's very easy because of this. Is we have to our image is image, and we have to R in it. So of course it will brighten our image. This is the original image, and okay, I am so brightened image, and it is R. Oh, sorry. It's add. I just made many mistakes. I've told you many times. So let it be add. Yes. You can see it's just got brightened. We have added the white. Let's add one more time. Add 2 equal to cv2 dot add. First image is add. Second image is R. I am so more brightened, and our image is add 2. You can see so white. If I will add one more time, it will get all white. You know. Now let's darken our image. Okay. So subtracted equal to cv2 dot guess the function. Oh yeah, it's subtract. It's so easy. No? There's no means to learn anything in this. Just normal English. Image. Uh, and after that, we will make an mm, let's plot this first. I am so subtract subtracted image. It will get darkened. Subtract. Okay. Spelling error. Uppercase, lowercase error. You can see this is so dark, so black. Okay. Let's do one more thing. Let's minus uh you know from this. No, actually, yeah. From this, let's minus this. Means the pixels. These pixels from this image. We'll do like subtraction 2 equal to image minus R. It will minus 100 everywhere. I am so subtracted and subtraction to uh, see this image is just subtracted from this, and if we use the function it's like this. That's why we use a function and not general maths. Okay, so this was all about arithmetic operation. Yeah, this was all. Now we will jump on the bitwise operator. Wait, text. Bitwise operator we use to plot an image on another image, or add the image, or subtract the image. Okay, so first we will make an image square equal to np dot zeros 300 into 300, and it's np dot ui nt 8. Okay, to let plot this. I am so blank, and this is square. Okay, so let's plot, and yes, let's plot the rectangle on this. Add the rectangle. It's like plotting rectangle functions. So what is our syntax is civ2 dot rectangle square 50 50 its starting point, and 250 250 its ending point, 255 its color, that's white, and -2 is its width. Yeah, you can see that we have plotted the square. It is square in square because it's equal dimension points. Let's plot some ellipse. Ellipse. Okay, sorry. I have to change the, you know, starting point, ending point, 150, 150, 150. This is color, and this is width. Okay, this is a ellipse and we have plotted it. But you will ask, these are so many parameters. What are these? So just don't ask me. You know how what to do. Copy the selection. Open ChatGPT. Go to ChatGPT and just paste it here, and your GPT will tell you everything. So wait a minute. Yeah. First is center, then is axis, then angles, then start angle, then color, then thickness. So this is how ChatGPT describe everything. Just copy the line of code and paste in the ChatGPT. You should learn this because you will always wait. Yeah, you will always make an uh, some in some point you will stuck in the code like I stuck in explaining something. So this ChatGPT will help you. So this is our first image which we have drawn with rectangle functions, and with this is our second image which we have drawn with ellipse function. So our first bitwise operator is AND. You know what does the AND does? AND means it will take the common features only. So let's start cpt2 dot bitwise and bitwise and it's square and ellipse. Likewise, we will plot, we will do every operation. You know, we will do OR operation, we will do XOR operation, we will do NOT operation, and equal to C. Oh, sorry. Uh, this is the reserved keywords. So we should change this or XOR not. The fuck is ellipse is not defined. C with 2 equal to. Okay, so by mistake I have done given the same name here. Let's change. Okay, now this is okay. Let's plot everything. I am so function 4 times. Okay, okay. First is the name and or XOR and not. Then the comma, 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 comma. Then the variable name add or XOR and not. It's and what I do. Sorry. Yes. So first is and. Mm, it just not. It does not seem like and. Square and ellipse. This square. This is ellipse. And bitwise. Bitwise and or. Wait. There is some error here. Actually, I have not rerun this cell, so it just got some confusion. Okay, so this is and, you know, sum of these two, and this is or the thing which is common about, this is XOR, and this is not. So this was all about, you know, uh, for bitwise operator. I think this much is all out. So this was bitwise, and this for arithmetic operator. We have done this segment also. And what is the convolutions, blurring, and sharpening? So this is very important. You know, convolution, you have heard many times of convolution, but people don't know what is convolution. So let's search on the net what is convolution. Uh, which convolutes, uh, yeah. So HSGT, what is convolution? So convolution is basically how to add two things and make one new thing. So it's like we have three numbers and three number this side, like 1 2 3 and 8 9 7. It's like, so it's like this is 1 2 3 and 4 5 6 9. So how should we add them? This pattern is called convolution. Okay, and if you have to study, you know, you have to know what is convolution, then just go on YouTube, and I will recommend you one video you should watch. What is convolution? Yeah, this video.
Suppose I
What
give
is
you two.
what is convolution? I will give you the link in the description, but you should check out this. Wait, I'll show you. Yeah, this is a convolution, and in this, in the term of image, how it work is have a kernel. It's like this is a kernel of 3 by 3, and it's like kernel will be placed like here 1 2 3 1 2 3, and this will sum, and this summation will be here. And when it move here, it like kernel will be go like this, and then the kernel will be here like this. Summation of kernel will be here like this. So this will create blurring blurred photo. So this was what convolution, and if you have to study, you know, convolution is a very important topic. So I recommend you to see that video that I have mentioned in the description. What is convolution? So that you will have better understanding is what is convolution actually. So let's go for convolutional operations in our ID collab. Okay, let's come to the collab, new notebook. Uh, First step is copy this thing and paste here and change the name to Cono. Okay. Oh. So let's take some beautiful image. No, from here, something beautiful. It's like flowers, you know. Oh, here any flowers. Here, flowers. .jpg. Just copy the part, cross this. I'm read equal to, sorry, image equal to cv2 dot imread, and here I am so, and here is flowers beautiful like you, and our image. You can see that how beautiful they are, flowers. Okay, so our first step is we will just blur our images, you know and how to blur our image is convolution will take the part. Wait, where was that? Yeah, in this video there will be some point he will teach you. I can't show you whole, but uh, the basic ones maybe it would be in this video. uh, yeah,
a given image.
this is
And
the
I should say the
wait,
animations.
see this is kernel, and this is the convolutions kernel is making. Kernel convolution kernel is making. Okay, so this is all about this video. I don't want any you know restriction from YouTube or copyright strike. So let's go. Okay, so first we will create an kernel of 3 by 3. Kernel 3 by 3 equal to np dot ones 3 comma 3, of course 3 comma 3, np dot, it will of float type, and it is on kernel, not an image. That's why we are not taking it at uint8. Okay, so we have made our kernel. After creating our kernel, we will use cv2.filter2d algorithms. It's an cv2 function to blur an image using a kernel. Let's see how. Blurred equal to cv2 dot filter 2d. Okay, here first parameter is the image, the variable image is stored, and second is -1. What is -1 is like, I will show you practically, cause theoretically you will forget about it. And then kernel is what are 3 by 3. Okay, so I am so blurred images. Okay, you can look, it's clear, its clarity is high. It's not enough blur, but it is blur. Blur depend on the kernel size. Our kernel is of small size, that's why it's little blur. And now question is, what is -1 in this? So what we have to do is copy the selection, go to ChatGPT, maximize this, and paste here. Okay, so here -1 is the second argument specified is it shows the depth of the image. Okay, and now let's make a bigger kernel so that our image could be more blurry. Okay, just copy, paste. Kernel will be our 7 into 7, and its size is of course 7 into 7, float 32, and here it will be divided by this every time the multiplication of this 7 to 7, that is 49. Above we have done upon 9 cause it's 3 by 3. Okay, keep in mind it. Okay, then convert it into 7 into 7. Probably a blurred image. You can see how blurry it is. Next, this was the kernel technique which we did right now, and my favorite technique to blur. But in doing projects, you have to do, fast blurs. So here are some fast blur techniques which can blur the image in one line only. Other blur techniques. Okay, what are the blur techniques? Okay, so first is uh, blur equal to cv2 dot blur. Of course, blur function is blur, and then the kernel size, let's take 5 by 5. This is first, and second Gaussian blur. You have probably heard of this very common blur we use, dot Gaussian blur image 5 5 to 0. Okay, box. And last is median blur. Median equal to cv2 dot median blur image 5. Okay, so why do we blur the image? We blur the image so, you know, we don't want this much blur, but we want, to remove the noise. It's like in an image, there's some features are here, you know, like this feature is more, this feature is less. So after blurring, every feature are the same. Okay, this is why we do blur. Let's see different type of blurs here. I am so, I am so, I am so, I am so. Okay, first is convolution blur. Okay, convo blur Gauss median. What is the name of convo? Blurred. Okay, it's blur. It Gaussian. It's median. Yeah. So this was convo. Yeah. Okay. So this is convo of 7 by 7. This was blur. It's quite good. This is Gaussian blur. You know, that's why we use it repeatedly. Is like, you know, it have quite more feature, but it's have no noise. All the features are the same. And you know, actually, we can't say noise because noise removal is another concept, but it does not have means random features like here is more, here is less. It like equal features everywhere. And this is median blur. It's like far are deforming here. Here is not so much deformations, so we use Gaussian blur. Um, uh, is like Gaussian blur more. Okay, okay. So in this, noise is removing, but this edge is not sharp. To keep the edges sharp, we use a type of blur which is bilateral blur. Let's see it. Bilateral. You know, this will keep the edges sharp and remove the noise. Filter. 75, 75. Yeah. Y- First see the edges of this and now see the, oh, wait a minute. Oh, okay. Yeah, yeah. Sharpened than this. Uh, Wait, I will show the original image. Okay, so original image is like this. Uh, After seeing the original image, these edges are all like sharpened edges. Everything we can look is great, but noise was removed. Okay, and now on other things which we have to do in this is, you know, blurring we have done, operations that we have done, denoising we have done, sharpening we have done. Let's do some other way of removing noise, है ना? Let's go. Yeah, let's remove the noise. Image equal to cv2 dot im read, and we will take here, you know, let's take something new. What is this? Like just copy part control or on original image. Okay, so you can see this is an image and you can see the noise here. You know, this light or eyes coming out. So we have to remove this. How will we do this? Uh, we will use an algorithm called fast and one means denoising colored. You know, uh, it's like this. And when you are trying these algorithms or doing functions, remember use chat gpt, cause you will not remember what function have what parameter, cause there are list of, you know, functions and algorithms. You can't learn everything, so you should be clever, and you should learn how to use chat gpt for being an efficient computer vision engineer or an engineer. It's the era of AI. You should use it everywhere. Okay, now this CV2 has no attribute. Okay, what I have done now, you know, okay, I have done this thing. Ah, look, its aura is gone. It's some blurred effect, but aura is gone. It is more helpful than this in the what you say in the concept of learning an image. Okay, so our last way to remove the noise is kernel way. First we will make an kernel, and we apply filter to the thing. We apply the kernel sharpening here. See this. It's the sharpening. Actually, we do not remove the noise here. We just convert its edges and make it sharp. Wait, I will make it if mm, okay, yeah. So you can see the boundaries. It's more sharp than this. You know, we can make a counters from this is easily, like these are trees, this is lamp. How can we segment this? For that we want that our image should be sharp, so we sharp our image like this. So with this, our third last topic of our today's videos end here, and now we just have two topics left: thresholding, binarization, adaptive thresholding, dilation, erosion, and edge detection. Okay, so we will make a new collab notebook and we will do these two in that. Okay, it's like basically 10 or 15 minutes videos left. I know that video is stretched to 22.5 hours, but you know, you can see what you have learned so far. I have taught you every every algorithms, every functions which you want to or you have to learn, because these all are in demand in the market, and you have to use it for making your computer vision projects or other image recognition and other projects. Okay, so first is, what is thresholding? What is thresholding? Thresholding is just like making and uh, like thresholds. Like, what do you mean by threshold? Like upper limit and lower limit. This is the original limit, like, and we have made a limit that if the pixel quality is above this, then all is the black, and below this, then all is white. So this is the binary thresholding. This is inverse thresholding, this is trunk, and after thresholding this image, we have done this, that pic, yeah, the color before this will be black, and after this will fade and be white. And this is simple, that this will be as it is, and this will be like, after this, every color here will be black. Okay, so let's see how to do these things in the coding part. This is some algorithms of thresholding. We will study how to do this, and this will be all in this topic. Let's start coding part. Let's go. uh, let's open the collab. Mm, New notebook. Threshold. Okay. We will name it thresholding. First, let's import everything. Okay. So thresholding, I have already told you what is thresholding and have shown you the algorithms. Wait, yeah, these are some algorithms: trace binary inverse. Okay, so this. No, this is binary. This is binary numbers. And after that, to zero, this is to zero inverse and mask. Mask is not here. Oh, trunk is not there. Okay. So these are some algorithms, and these are some mathematical formulas. How these algorithms work. And now let's see how can we apply this algorithm. So first of all, we go to the browser and just write uh, a page of a book. Uh, Okay, so this is a book page. Yeah, this is a book page, but it's multiple pages. Oh, let's take this. Okay, just save image is where you want and close it. Close it. Yeah. Now I will tell you how to add something on Colab, uh, which is available on your disk. It's quite simple. Just uh, no, upload, download, you know, the file you want, and just copy part. Then you know what we will do is like image equal to cv2 dot imread, and just like this. Let's see the image. I am so it is original, and the variable in which image is stored. So this is our book image. Let's apply our tracing things on this. Let's go. So for tracing, we unpack our function with two things. Ret. This give binary number like 0 and 1, which tell that the task is done or not. It's like true or false. Okay, and this will give the value. Okay, equal to. And then we will add our threshold functions as usual. Threshold and image 127 255. Okay, so again, what are these numbers? If you want to know about these numbers, just do chat GPT. I know you are so uh, what I say. um, you are. Wait a minute. Oh, sorry. Okay, I know you all will not do chat GPT, of course, majority of you. So I'm doing for you. Wait a minute. Uh, chat GPT. Okay, just paste here the code. So what is 127 and 255 here? Yeah, this is the threshold value. Pixel in the input image with intensity value greater than. Okay, although you can read this, or it is the threshold values, starting value and ending value. Means all the values from lesser than this will be 0, all the values less greater than this will be 1. Malab means 255. Sorry, I just speak Hindi sometimes cause I'm from India. So sorry, my first listening is Hindi. I'm not so good in English, so sorry if I say some words which you don't know the meaning. Okay, so let's make the let's make it for 5 different algorithms. Okay, 2, 3, 4, 5. And first we take binary, then we will take binary inverse, then we will take a trunk, then we will take to 0, 0, then we will take to 0 inverse, to 0 inverse. Okay, let's just check everything. I am so algorithm names and this and here trace. Okay, just copy. Okay, first. So this is binary. This is binary inverse. This is trunk. This is to 0. And this is to 0 inverse. So after this, you will be able to make threshold value easily using different algorithm. Let's okay. Oh, hi. Okay. So what happened is, you can see the color is outbursting. This is happening because we didn't make our image in binary form. Wait. Okay. Now it is in binary form. Let's do. Yeah. Okay. So this is the original one. Let's see. This is binary. It's pretty good, you know. And binary inverse. I like, black and white. I like this font. It's aesthetic one. Trunk. It's something blurry, but okay, good. To 0. This is also good. To 0 inverse. Uh, Here I can't understand some words. So yeah, it's not so good. So these are some techniques of thresholding. And now we will see some adaptive thresholding. Adaptive thresholding is like it can have its own threshold values. You will not again say that justify that this is the threshold value. This is you have to find the threshold value. But in the adaptive threshold parameters, you don't need to find threshold value. Let's make one adaptive threshold value. So start like cv2 dot adaptive threshold. Here we will add image 255 cv2 dot adaptive trace means this is an adaptive algorithm. And now we will give it 10 thresholding algorithm. 3 and 5. Okay. Control C, and now I am so adaptive volume. Okay, it's not pretty good, and it's because you know it's it's not it have very much noise. So let's first clear the noise. Blur equal to cv2 dot Gaussian blur Gaussian Gaussian and kernel 5,5, 0, and here we will add blur blur. It's got worse. Okay, so you can change some parameters here and like make it correct, but after this seeing this, I would say that to zero is like best of all these algorithms. Then okay, so yeah, we also have an lab sk.image.filter means this is a function actually library from threshold local, and actually it is an algorithm. Okay, so in this algorithm we just is convert our image from bgr to hsv, and then in the hsv format we use we just apply Gaussian blurring to our image, and then we it's like apply the thresholding. Wait, wait. Okay, so it's throwing error. Yeah, and if our any function or any code is throwing error, what we generally do is we go to ChatGPT and ask for help. Like, hey ChatGPT, can you help us? Okay, it is telling, but he's not saying that we are getting the error. So it's like just copy our error and give it to ChatGPT. So you know, you need to make sure that implement has a number of. Okay, so this is happened because it expect three channels and we gave it one channel. Let's convert it again. Wait, Okay, so see, this is the best because we are doing Gaussian blur here, converting our image in HSV format so that we our algorithm can access it and give us result more accurately. So let's go on the next topic, which is dilation, erosion, and edge detection. So what is dilation? Yeah. So you can see this is our original image. What is dilation is just we add some more layers at the boundary like this. This is our original image and this is the boundary, extra boundary. This is the extra boundary. What is erosion? Erosion means something which get damaged. So here our boundary get damaged or we remove our boundary here. You know, you can see like this and that is dilation and erosion. And what is opening and closing? So what is opening and closing is, wait, I will show you. Wait, maybe I would have some picture of it. Okay, so I don't have picture, but uh, I don't have any picture of opening or closing, but opening is just first we do the erosion, then we do the dilation, and closing is like first we do the dilation, then we do the erosion. In opening, first erosion, then dilation. In closing, first dilation, then erosion. Okay, so let's see these things in the code. So let's go and code it up. Mhm. Let me just okay. We have already unzipped all of this, so let's see. In the image, we will have an image which I have kept here, named what is its name? Image. Hmm, Wait, we have taken this image, sorry, inverse image, this image here. Oh, actually, yeah, this image here in the black and white means binary form. Let's perform some task here. Let's see how our images. Oh, let's do some dilation and correlation, opening and closing on this. First, we have to do is make kernel. I have taught you how to make kernels. Like we will make a 5 by 5 kernel, and its value will be np.uint 8. Okay, we have made a kernel. Okay, So first we will write a code of erosion. Yeah, uh, we will use cv2.erode function. First we will add image, then kernel, then iteration. Iteration is the number of time it will do. Okay, so like this. Same is for dilation. We will use dilate function, and for opening we will use morphology x. It's a function of cv2 in which okay, that searches on Google. Although this is an algorithm of opening with the image, and this is the kernel size, and this is the image size. This will open make an opening image, and same like this is for closing image. So let's see how our algorithm does. Okay, so first thing, this is our image and erosion. In erosion, the inner and outer boundary will go. Wait, yeah, you can see outer and inner boundary will go, and after this is dilation. In dilation, extra boundary will come. Extra boundary has come, and in opening, what we did in opening, first erosion is first erosion has happened. After that, dilation has happened. So first boundary has gone, then boundary has come, and here first boundary had come, then erosion gone. So closing is better than opening. Okay. So this was all about dilation, opening, and you know closing, opening, dilation, and last is canny edge detection. What is canny edge detection? Okay, uh, let's see a formal definition first. What is canny edge detection? Canny edge detection is a popular image processing technique used for detecting edges within an image. Okay, so it's all about what is canny edge. It just find out these means this is our image, this is the edge, this is the edge. Image is going down and coming up, so this is the edge, this is the edge. It just gave us the all the edges of the images. So let's apply in a code and end this video. Okay, so first we will see London Xmas, which we used for before. uh, Image equals cv2 dot imread image and London Xmas. Okay, for making can image we will use a function cv2 dot canny, c capital of canny, and first parameter is image, and second is 50, and then is 120. So what is this 50 and 120? This is the minimum value and this is the max value of our edge detection derivative. So let's put let's plot our image. uh, i am so I am so can I, and uh, it's like oh, image, sorry, it will show you the image. I have to put here Kenny. So this is the, we got all the edges. Let's make different can images from this. Control V, Control V, Control V. Oh yeah, does uh, we will say can it 2, can it 3, can it 4, and we will change the min and max value and see how it will affect our images. Okay, let's plot everything. Controls 1, 2, 3. Can it 2, can it 3, and canning 4. So this is can image. Oh wait. Okay. So this is the can image. Uh, when we have changed the parameters, this have so many edges. This have less. This is perfect. So we have to change the minimum and maximum value and select how many edges we have to keep in the image. So this was all about the lecture, and with this our lecture come to an end. And sorry for my city English, but it will improve with the further lectures, and hope that you liked this lecture. And so these two topic has covered. In a next lecture will be of uh, maximum 1 or 1.5 hours, in which we will do image segmentation. And what is image segmentation? Image segmentation is just a process in which we separate the things which we see in the images. Okay, so this is all for today's video. And of course you all are new because this is my new channel, and if you like our videos, then please subscribe. And if you are watching this from India, and from North India, the Hindi lecture will become when this playlist is over. When all 8 videos will be live, then after that I will be I will make all the video again in the Hindi language. Okay. For then, until then, thank you. My name is Ritam Balik. You were watching Balik Robotics. Thanks for watching. Subscribe channel. Thank you. Bye.